Good evening, good afternoon, good evening, welcome. This is the second in our 2016 Winter Series on Aging lecture series. My name is Ken Ottenbacker. I'm the Associate Director for the Seeley Center on Aging, and I'm standing in for Dr. Volpe. Dr. Volpe is out of town and won't be able to join us this evening. So I want to remind everyone that the Winter Series is named in honor of Dr. Lefeber. And it's a series of 6 lectures. We had the first lecture last week. We have introduced Dr. Kathleen Welsh-Bohmer in a minute from Duke University. But I'd encourage you to look at the paper and look at your emails, because there are 4 more lectures after tonight. And we'd love to have you come and be a participant on part of the audience for all 6 of the Winter Series lectures. So we're delighted this evening to have Dr. Kathleen Welsh-Bohmer from Duke University join us for the lecture. Dr. Bohmer is professor and chief of medical psychology in the Department of Psychiatry and Behavioral Sciences and director of the Joseph and Kathleen Bryan Alzheimer's Disease Research Center at Duke University. Dr. Welsh-Bohmer completed her BS at Duke and her master's and PhD at the University of Virginia, all in psychology. She received her postdoctoral clinical training in neuropsychology at the University of Iowa. Dr. Welsh-Bohmer's research interests over the past 25 years have centered on defining the early expression of Alzheimer's disease and other neurodegenerative dementias with an aim of facilitating disease prevention. She has led large epidemiological studies to examine the prevalence and incidence of late life dementias in relation to environmental exposures and biological determinants. Her work has been funded by a wide range of federal agencies, foundations, private organizations, and industry. Dr. Welsh-Bohmer has authored over 200 peer-reviewed articles, book chapters, and reports exploring the cause, treatment, and prevention of dementia and Alzheimer's disease. Currently, Dr. Welsh-Bohmer oversees the neuropsychology scientific operations of a phase 3 global clinical trial to delay the onset of Alzheimer's disease, entitled the Tomorrow Study. The methods her team is developing for this study have important implications for accelerating global clinical trials in Alzheimer's disease prevention. She's going to speak to us this evening about advancing the prevention and treatment of Alzheimer's disease. Please join me in welcoming her to UTMB in Galveston.
Thank you very, very much, Ken, for that very nice introduction. I want to thank the organizers for inviting me to speak to you this evening about some of the work that we're doing in the area of prevention and treatment of Alzheimer's disease. And I'd like to thank all of you for making time to join me here tonight to hear about our work. I really appreciate the invitation to come here, and appreciate it all the more today when I had the opportunity to meet with faculty and students here at UTMB. You have an amazing team of investigators that are developing here, and to hear about the work that you're doing was frankly inspiring to hear what some of the young people are working on and where this can go in the future. And that's what we need to encourage, are more young scientists coming into the field, advancing us in new and novel directions. So I applaud you for the work that you're doing here on the campus. What we'll be doing here today is sharing a little bit of the work that has been underway at our various projects that you'll see funded, the funding lines on the right-hand side of the slide. I always have to start, of course, with my disclosures. So as you've heard, I am the neuropsychology lead for a global study. It's an entirely pharmaceutical-supported study called the Tomorrow Study, and that's funded through Takeda and Zinfandel pharmaceutical companies. I also have some consulting arrangements and contracts with a variety of pharmaceutical companies and small tech companies, and I'll touch a little bit on the Tomorrow Study towards the close of my presentation, and a little bit on some of the work that we're doing with technology as well. So I'd like to begin by showing us all the face of Alzheimer's disease. And I start with the face of Jane. And although Jane is actually a fictional character in my slides, Her story is, in fact, a very real story. So we have Jane here, and Jane is saying that she's been noticing problems with her memory, embarrassing problems with her memory. It seems to be better with this. Is this better? I think I'm going to talk into the mic. So she's been noticing some embarrassing problems with her memory, and this has been going on ever since she retired from her job. She's having difficulty knowing whether she's been telling people her stories about her kids and her grandkids, tracking her conversations. And so she's embarrassed by that and concerned by that. She brings us to the attention of her primary care doctor, who runs all sorts of laboratory tests and even does a brain imaging study that all come back normal. And Jane knows, however, that Alzheimer's is running in her family. This is what has sparked her concern and brought her to medical attention. And so she's always been prepared for that possibility that one day this disease may affect her. Her family knows that she's concerned, and they continue to reassure her, and they tell her, you're doing everything just the way you've always done them, and you're quite functionally capable. They remind her that her laboratory tests have come back normal, that the doctor's not concerned. And yet, she's always been wondering in the back of her mind, is that day coming? Is that day perhaps already here? Do I have Alzheimer's disease, or is this just what I should expect with normal aging? And regardless of whether this is normal aging or the beginning stages of a disease, is there anything I can do about this? Jane's concern is actually a real concern that's shared with many, many people. And in fact, in one survey from the Harvard School of Public Policy in conjunction with the Americas Europe study in 2011, they reported physicians that were surveyed in this survey indicated that in their patients, Alzheimer's disease is one of the perhaps biggest concerns, and it is among the most feared diagnoses in the population over age 65. And this concern is actually a global concern. As we've been making medical advances in the field, we've been able to improve access to health care, and it's led to a longer life expectancy, and that's been happening globally. And yet the treatments have not kept pace with the developments that we have in terms of extending life into late old age. And so as we see people now aging into the oldest part of the population, we see an increase in the prevalence of age-associated illnesses. And as such, we're seeing people living with these chronic illnesses, Alzheimer's disease being one of those illnesses that will occur as people get older. And this is really presenting an enormous public health challenge as we look at the numbers that are being affected in the years ahead. Next series of slides will actually show you what the scope of the problem looks like. So this, the first slide that I show you here comes from what was called a Delphi consensus study that was reported about a decade ago in 2005. And at that time, based on the estimates from population-based studies, the prevalence of Alzheimer's disease globally was projected at 24 to 26 million people living with dementia. And that does not include the milder forms of mild cognitive impairment. At that time, projecting out what the numbers would look like going forward as the population continues to age, the projection was that there would be 42.3 million people globally affected in 2020 and 106 million by 2050. However, it was recognized even then that many of the countries that were anticipated to have the largest population growth in the sector of the population over the age of 60 were not well represented in this consensus statement. So many areas that you can see in this slide that are in white are areas where there were no population-based studies to inform the estimates. And yet there was good information from the UN Secretariat that in fact those are the areas of the globe where we would see an explosion of growth in the age over 60. More recently, in 2013, the results from the G8 Dementia Summit have updated the projected prevalence across the globe, and they now have included studies that were representing areas that were not well represented in that initial survey. So there are 75 new studies published now in China, 7 in sub-Saharan Africa. So in that first study, there was only one study that was being done in Africa, and that was in Nigeria. And so now with the revised numbers, we're seeing that the projections are probably 20% higher approximately than what was originally proposed, and that we're looking at not 105 million, not 115 million as one projection subsequent to that Ferry study was reported, but actually 135 million people globally. So we're talking about a huge crisis that we're seeing within the next half century in the number of cases of Alzheimer's disease across the globe. So you're probably sitting there saying, that's troubling. But how are these statistics relevant to the prevention of Alzheimer's disease? And I'd say they're very relevant, because Alzheimer's disease is not a theoretical possibility, it's a reality, and the reality is now on our shores. So these are the numbers that we currently project affected here in the United States. Currently, there are 5.4 million Americans that are affected by Alzheimer's disease. The vast majority of those 5 million are over the age of 65, but a significant segment, about 500,000, are people that are under the age of 65, many of them quite young, actually. It is considered the 6th leading cause of death, and currently it's costing $200 billion in annual healthcare costs. That does not fold in the costs that are being absorbed by families who have to leave the workforce to care for patients that are having dementia. And we expect that that's about 15 million unpaid caregivers. Without a cure, the numbers that we would be looking at in the year 2050 are 13.4 million Americans affected by this disease. And when we project that out in terms of costs, the current costs that are estimated are about $1.1 trillion annually. It's just simply not sustainable. It's given us pause to think about this problem differently. If you've been reading the news, you hear almost on a fairly regularly monthly or at least quarterly basis about a new treatment that was tried in Alzheimer's disease. It was looking very promising, and yet it failed. And so it's made us step back and say, well, what if we don't have a cure anytime immediately? Can we still have a public health impact on this illness if we revise our goals and try to have a more modest impact on the illness? And so it was reasoned, what could we do if we could simply delay the onset of symptoms of the disease by 5 years? So we're not talking about curing it. Let's just push onset from 65 to 70 in a person who was destined to get it at 65, or move it to 80 for somebody who was destined to get it at 75. Looking at these projections, there would be 8.1 million Americans affected by 2050, as opposed to the 13.5 I showed you before, giving us a net savings of 5.3 million Americans that would be saved or spared from the illness over this time period, with a net decrease in cost of approximately 40%. This has caught the attention of policymakers. And they reasoned that if we were able to develop a therapy that could effectively treat this illness and it became available in 2025 and could delay the onset of symptoms, that within the first 5 years after introducing that treatment, there would be 2.5 million fewer Americans affected in those 5-year periods, and that comes at a cost savings of $220 billion over 5 years. So just moving the onset by 5 years could have a significant public health impact, and it can also have a very personal impact for a lot of people that were destined to get this illness. So based on that observation, in 2011, if you can believe it, there was a law passed that was enacted and passed by both houses of Congress and signed off by President Obama, called the National Alzheimer's Project Act, NAPA. And this creates a national strategic plan to address and overcome the escalating costs and the crisis of Alzheimer's disease. The goal that was announced in 2013, after it was rolled out, was to develop treatments to slow the progression and to prevent the onset of Alzheimer's disease by 2025, and hence the title of my talk, Preventing and Treating Alzheimer's Disease by the year 2025. More recently, in 2014, Congress added another $100 million to the National Institute on Aging's portfolio for Alzheimer's research. They doubled what I thought was really exciting, the investment going into the so-called BRAIN initiative, which is the brain research through advancing innovative neurotechnologies that's put in place and important for developing new insights and innovations into treatment. Over the last year, as experts have convened with Congress, it's been recognized to really meet that goal of trying to have a therapy by 2025. We're not talking about that long a period of time. So had you asked me a couple months ago, I said we had 10 years. We don't even have 10 years now to be able to get that therapy. So we're talking, if we're really going to get serious about it, the amount of money that's been put into Alzheimer's research would need to be increased quite substantially. And so the ask that was made at the time of the summer was that we would be required to have $2 billion annually over the next decade in research funding. In July, NIH requested an additional $323 million in Alzheimer's disease funding that would be over and above the $737 million base appropriation. And just this past December, we were approved for an additional $350 million in Alzheimer's disease funding. And the areas that I highlight here are actually the areas of therapeutic development. So $92.8 million would go towards translational research and developing clinical interventions. And that's not just compounds. That's interventions that would help people to stay in place or would actually help to alleviate some of the comorbidities that they may have or other problems that they're having. And another $35.4 million was put in place or earmarked to help establish and support research partnerships between public and private sectors. And this is really going to be important because in order to solve this illness, we can't expect the federal government to fund it entirely. It's an enormously complex illness, and it's going to require resources that come both from the community as well as from the government. So where are we today? Well, I'm going to be sharing where we are today. The bad news, I'll just get to the punchline. There is no treatment currently that will allow us to prevent the disease from occurring, nor is there a treatment to stop the disease once it has started. But the good news is that there's been considerable progress in our scientific understanding of the biology of the disease, the advances that are being made in technology that are allowing us to make an earlier diagnosis, which means that we can intervene with treatments when it really matters. And there are now evidence-based approaches that are helping us look at how we might lower risk and promote healthy cognition. So I think on balance, the good news is beginning to outweigh the bad news in this scenario. And what I'd like to do today is just share a bit of the work that we've been doing in this area of prevention. I'm going to be focusing on our prevention studies that we've been doing in the field and how that's now informing some of the approaches that we're taking in terms of developing therapies and other types of behavioral interventions. I'll start by first illustrating the unique contribution of epidemiological studies to our current understanding of the impact of Alzheimer's disease across the lifespan. I'll then move on to discuss prevention and treatment approaches that are underscored by this approach. And I'll conclude by considering some new treatment approaches that are designed to prevent disease and optimize cognitive health. So let's begin. First, let's look at what is the contribution of epidemiology in understanding this chronic disease, and does that give us some ideas of what we might be able to do to prevent it? I'm going to share with you the work we've been doing in a project called the Cache County Memory Study. So this is the study of the Cache County Memory Study is in the state of Utah. Let me see if I get. And so you can see up here at the top of the slide in this red part of the various counties that are highlighted, this red county up here is Cache County. So it's up on the Idaho border. And this study was begun in 1994, and it concluded its data collection in 2007, but we continued to mine the data that we've developed. And it was designed to look at monitoring not only the trend of dementia out in this area of the country, but also for identifying the risk and protective factors that might be important for the development of Alzheimer's disease. So this is a picture from the campus of Utah State University, which is where the study was headquartered out of Logan, Utah. And it involved collaboration with Utah State University that really housed the cohort that was critical for the study, with the scientists that were guiding the study coming from Duke University, Johns Hopkins, and the University of Washington in Seattle. As I mentioned, it began in 1994 as a prospective epidemiological study, so following people forward. It was population-based. It was intended to get everyone in that county over the age of 65 to participate. And the goals at that time were to examine the genetic risk factors and environmental exposures that might be related to cognitive disorders in general and Alzheimer's disease in particular in a population that included a large number of people that we would consider the oldest old, so people that aged into the ages of 90 and older. So you might ask, well, why Cache County? I thought Duke was in Durham, North Carolina. Well, there was a good reason why we went to Cache County. First, we were introduced to investigators that were out in Logan, Utah, that told us about this very unique population that they had available that would be ideal for studies of aging. However, they weren't behavioral scientists that were in place to do epidemiological studies, so they asked, could we partner with them? They had the cohort, we had the expertise in running these types of studies. Well, what was so special about Cache County? Well, first, it's geographic location. So you can see here in this picture, this is the county, and it's located in a valley along the Wasatch Mountain Ridge. As a function of where it's located, there was very limited in and out migration, at least in this older age group within the county. And that makes it ideal when you're trying to follow up and see what happens to people over time. You can find them because they're not moving out of the area. Importantly, the median life expectancy in this county exceeded the national norms by about 10 years. So at that time, men were living to about, on average, 85.7, which was above the national norm of 74.8. And women were living to 88.1, again, over the national norm of that time of 80. So we saw that there was exceptional longevity in this area. Now, it's not the only area of the country that enjoys that, but it was one area where we had good longevity. A lot of the things that often complicate our ability to detect diseases were reduced in this population. So there was very little alcohol and tobacco use, likely attributed in large measure to cultural factors. So 91% of the population over the age of 65 came from the Church of Latter-day Saints. And so there were prohibitions on alcohol and tobacco use. In addition, they have high educational attainment in the valley. So 81% have high school education or higher. Again, that simplifies the task of trying to determine whether or not you're looking at a cognitive impairment that's due to a disease. Importantly, very close-knit community, so they had a limited number of health providers and pharmacies, so we could look things up pretty readily. And they had really great response rates, and this is really key in epidemiological studies, that 90% or more of the people would consent to being in the study and remained in the study over the long term. And so that's often the bane of epidemiological research are the response rates. If you don't get good representation, then your estimates may be quite a bit off. So in order to do a study of Alzheimer's disease, we have to make sure that we are capturing all the cases. But a problem with that is that to do a full clinical evaluation in 5,000 people is just not practical. So the way we did this was a staged screening approach where we screened to make sure that people with cognitive impairment were identified or suspected cognitive impairment were identified, did a clinical examination, then if that looked like it was positive, a physician went out into the home, and then there was a follow-up 18 months later. And then we followed people for 4 waves, approximately 3 years apart. So there was the first screening wave in 95, one in 98, 2002, and 2005. So we're following people for 12 years with this very detailed, staged approach. And here's what we found. So we had 5,092 people in the initial starting population, and nearly everybody, 97%, gave us DNA samples. And we've continued to bank those for additional studies. We made a careful and deliberate decision to also identify a panel of controls. We call them our designated controls. And those individuals also went through a comprehensive evaluation, even though we weren't concerned about their memory. And that's for case control studies. And that's also to make sure that we're not missing people. So it allows us to see the sensitivity of our detection methods by having a control panel that was included. So what did we learn from the Cache County study? Lesson 1. The question comes up, if we all live long enough, will we all develop Alzheimer's disease? Well, what we learned in the study is, in fact, the prevalence of dementia, no surprise, continues to go up as we get older and older. It looks like it's increasing in men and women, but it probably looks like it's not an inevitable part of getting older. And there appears to be a gender difference that I'm going to show you in a moment, where women seem to be a bit more vulnerable to the disease than men in late old age, that is after the age of 80. Now that finding is somewhat controversial. You don't see it across all studies, so I don't want people running out of here saying women are going to get it more commonly than men. It tends to be seen in a lot of studies, but it may also reflect the fact that there's a higher mortality rate in men, and so it may reflect differential mortality. So this next slide shows you the data from our prevalence survey. And so you can see, no big surprise, that the prevalence is very low in people who are in their 60s. And so men are in the Carolina blue and white, and women are in the yellow and green. And so you can see that it's basically the same between men and women till we get to about 80, 84. And then it looks like it's more common in women after age 85 and certainly after age 90. And what you see is that it looks like it's continuing to go up. Prevalence is a snapshot of how many people in the population at that point in time have the disease. So it's not how many have just developed, they've been living with the disease over time. Now the question about if we live long enough, we found that lesson 2 was that there is dementia-free survival. So when we looked at what we call incidence of dementia over the subsequent waves, we were able to look at how many new cases were developing over time as people got older. And what we saw is that there is a significant proportion, perhaps as much as 30%, that appear relatively invulnerable to cognitive impairment, like Alzheimer's disease, even if they live to be 90 years of age or older. And this was reported first in 2004 by Ara Kachaturian with our first incidence wave data, and later has been documented again with our subsequent wave data. Now, that's implying that the incidence or the new cases are actually beginning to asymptote out as people get into the older age ranges, and that has not been documented in all studies. So in some of the studies coming out of Maria Carrada's lab would suggest that the incidence is still growing into late old age. But despite that, regardless of which set of data you look at, and the inconsistencies across studies, what is clear is that there is a portion of individuals, maybe 20% and not 30%, that look like they're surviving a theoretical lifespan of 100 years without dementia. And we want to know what's so special about that 20%, because we'd all like to be in that segment of the population. The other thing that we learned is that genetics, of course, play a role, but it's not the only role. So ApoE, which is apolipoprotein E, it's a gene that's been long known as a risk factor for Alzheimer's disease, was in fact an important risk factor in the population. And that inheritance of the risky form of the allele, called the E4 allele, increased the risk of Alzheimer's disease in the population. But even so, there is a substantial number of people that have that gene that continue to show normal cognition into the late life adult span in Cache County. And that's shown here with Ara's data in the 2004 paper. So what you can see, these are survival curves, and they're showing the proportion of the population that's disease-free. So up here at the beginning at 65, nearly 100% are disease-free. And as we go on in later age, more and more people are affected. And what you can see, here we have like 50%. And you can see people that have 2 copies of that E4 allele, the ApoE4 allele, that's the risky form. So these people inherited a bad copy from mom and a bad copy from dad. You can see that they have onset that's substantially sooner than these other curves over here. So about 50% have developed cognitive symptoms at about age 83 or 84, as opposed to somebody with only 1 copy of that bad gene having the curve shifted to the right, so a later age of onset. And this group of people that did not have either copy of the gene pushed even further to the right. But what you can see is that there is an asymptoting of these curves here, and approximately 20 to 30%, regardless of what their genotype, are not developing disease at these later ages, at this later point. So that gives us some hope that this disease is not entirely being driven by perhaps genetics, and there may be something else that is ensuring disease-free survival. It may be other genes and not the ApoE gene that's protecting people and allowing disease-free survival, or it could be other factors in the environment that are contributing to healthy age across the age span. So lesson 3 from Cache County, we started to drill down on what are the factors that might be playing a role in disease risk. And we observed that in Cache County that the risk was not entirely genetic, and we published some of these findings in Joanne Sean's paper in 2013. There were a host of lifestyle factors that now are very well known that appear to play a very important role, and they include untreated vascular health conditions, and a number of common exposures, including some medications, have a relationship to Alzheimer's disease risk and to the onset of symptoms. And these effects can be exerted over different time periods in the adult lifespan. So what are some of those things? You've probably heard them many times now in the popular press. We focused in on the ones that we might actually be able to modify. So some of the things that increase the risk are sedentary lifestyle and obesity, poor dietary patterns, hypertension, heart disease, and diabetes, as well as low education, perhaps reflecting less capacity to compensate for problems once they begin, depression, and stress. And these factors are now actually quite well known in the world literature. This was a study published in 2014 that looked at the factors that are attributed as risk factors to Alzheimer's disease risk. And it was reported by Smith et al. That all genetic factors of Alzheimer's disease are believed to account for approximately a third of the risk. But many non-genetic factors have been identified, and they include some environmental exposures that you see listed here, as well as at the individual level, the lifestyle factors that I've just mentioned. And most importantly, what we know about these non-genetic factors are they are factors that are modifiable. And so that gives us some hope that perhaps we can have a significant impact on this illness. Just very recently, earlier this year, there was a very large meta-analysis that really tried to drill down on this more empirically to look at what is the state of the evidence for these various risk factors. This study looked at 17,000 population-based studies that were published from the years 1968 through July 2014. After going through some rigorous, looking at the scientific rigor of these studies, 323 were actually examined with great scrutiny. And from that analysis, 9 factors were identified as most reliably showing the highest consistency of the evidence as being related to Alzheimer's disease risk. And I've listed them here. They're actually also in the bar graph. So the ones that increase risk are here. I know you can't read this. The ones that are protective factors are down here, which are basically quite sensible. I'll tell you in a minute what they are, but they actually mirror whatever the risk factor is. It's like the risk factor and then how you would treat that risk factor is protective. So what are some of the factors? I've already mentioned them. Obesity, current smoking, carotid artery narrowing, type 2 diabetes, low education attainment, high levels of homocysteine, depression, high blood pressure, and frailty. And then what we see on the prevention side of this, so down here where you see many more bars, you would have things like healthy diet pattern, you have arthritis as protective, high folate, you have cognitive activity, light to moderate drinking, fish consumption, high education, physical activity, et cetera. So kind of mirroring what the actual risk factors are. And I was having a hard time without my glasses on reading my own slide. So this has led to a worldwide push of trying to prevent illnesses. And I would suggest we're not going to do what he's doing over here. That's not considered walking your dog. And watching TV is not cognitive engagement. And drinking a high sugar Coca-Cola or other drink is probably not a healthy beverage. But it led to the G8 summit that was published in 2014 with a call to the governments of the G8 countries to really start to make prevention of dementia a priority. And in the work of Kristen Yaffe, who's actually tried to see what would be the impact of trying to change some of these things. So this paper was published, I love this paper, it was published in 2014. And what they did in this study is they looked at if we were able to look at the 7 factors that we probably can do something reasonably could do something about. If we were able to reduce the risk of those factors by 10 or 20% in the population, what would that do to the projection of these cases of Alzheimer's disease? So they looked at the combined effect of 7 risk factors. They looked at diabetes, hypertension, obesity, physical inactivity, low education, depression, and smoking. And then they examined what the combined effect would be if they reduced that by 10% or 20% in the various countries. And what they found is that if they were able to reduce the prevalence of those risk factors by 10%, the Alzheimer's disease prevalence would go down 8.3% in those countries where they were able to do that. If you were even more ambitious and able to reduce it by 20%, 15.3% of the population would be reduced prevalence by 2050. And that comes to 16.2 fewer cases. So that I found pretty compelling, and I think many people have found that pretty compelling. And so it's led us to say, it's really time to begin to take, it's observational, it's not saying it's causal, but it's pretty compelling evidence that there's something there. And so it's time to translate that observation into action. And this is the role, I think, of the behavioral health sciences, geriatrics and gerontology, is to develop evidence-based approaches for healthy lifestyle changes which can be implemented at both the individual and the population-based level. This is really, I think, a responsibility of translational sciences now that are trying to implement these lifestyle behaviors, is that they must be rooted in a good science in terms of showing that the approaches are likely going to be beneficial. The ultimate test of whether something is effective is a randomized clinical trial. And you'll hear this time and time again, that observation is not enough. Let's see if we actually assign people to one condition or another, whether or not it has an impact. And so studies have begun to emerge that are looking at this. Some of them are looking at single domains, so they're just looking at diet, or they're just looking at physical activity, or they're just looking at social activity, or cognitive engagement. And the results from those have been basically done in either older groups or middle-aged groups, and they've been mixed. And I think in large part the studies have come back negative if they're being done in just completely cognitively healthy individuals. And there's probably a host of methodological reasons why that may be. And it may be that it's true, that it's really doing very little. But there have been some short-term gains, and those have been seen mostly in people who either have cognitive complaints or have already developed some cognitive symptoms, which we call mild cognitive impairment. And the longer-term gains about whether or not that's having any impact on Alzheimer's disease, the jury's still out, frankly, because we'd have to follow people for a bit longer to really have an answer to that. But a lot of that's going to hinge on compliance. And that's really the challenge, I think, in all of this, is it's easy sometimes for people to start something. Well, it's not that easy, but it's easier to start something. It's harder to sustain it. And we've got a diet industry in this country that's testament to how hard it is to keep people on diets, as one example. Now, the really interesting things are these multi-domain interventions, and some of you may have heard about the FINGER study, which is the Finnish Geriatric Intervention Study to Prevent Cognitive Impairment and Disability. And that's a 2-year randomized study that's basically throwing all these interventions at people simultaneously, saying, we don't care which one works, but let's put them all together. Maybe all of them together will work. And they just published their preliminary findings from the first 2 years of the study. It's a 7-year study. They just published the first 2 years of the work in June of this past year. And so let me just tell you a little bit about it, because I think it's a really interesting study that has attracted a lot of attention and has attracted our attention. So in order to look at whether or not people are actually benefiting, they decided they would increase the risk for having cognitive problems by a risk score. So people that were included in the sample had what they called high CATIE risk scores, and that was based on an algorithm that included age, sex, education, their systolic blood pressure, their BMI. So if they scored high on the scale, that meant that they had a lot of these risk factors. So if they scored 6 or higher, they were cognitively healthy, but in a risk group that suggested this wasn't a good pattern for them, and they could develop illness in the next 5 years or so. And the subjects were 60 to 77 when they came into the study, and then they were randomly assigned to either the intervention group or the control group, and I'll tell you about both in a minute. But the intervention group was multi-domain, so it was looking at diet, it was looking at exercise, cognitive health, vascular risk monitoring. They got intervention in all those areas. And then the control group just got general health advice. So they met with a nurse who would tell them about all these different things that were important to their health, and that if they got on a good diet, if they got exercise, that would be good for them. And that they were powered for 500 in each group, and they actually have close to 600 currently, and that's good because they're probably going to lose some people over time, as is typical in these studies. So it was an amazing intervention. I can't believe people stuck with it, but so they had a nutrition part with it, and they met for at least 3 sessions individually with a nutritionist, and they were in group sessions, approximately 7 to 9 of them with an interventionist. They had physical exercise that were done under supervision with physiologists, exercise physiologists, and they got aerobic flexibility and strength training. They had cognitive training. They had at least 10 group sessions with the psychologists and individual sessions, and then they had computer-based training that was done in 2 6-month periods, and in total they had 72 sessions. Then they had social activities that were just built in by having people come into these things, And then they had management of metabolic and vascular risk factors. So they met with a study nurse or a physician at those intervals that you see listed there on the slide that looked at their blood pressure, looked at their BMI, looked at other measurements, and then made recommendations back to their doctors. So very intensive work that was being done. And here are the data from the results that were just published this past summer. So what they found is that they looked at their primary specified outcome, which was change on cognitive scores, and it included 14 different measures. And what they found was that there was a mean change, it was small, of 0.022 between the two arms. And that's shown here. So that's their primary outcome measure. So the red, if scores go up, that's good. And so you have the treated in red, you have the control in blue. And so both are improving over time. And there is a significant difference, small but significant difference between the two groups. They also found significant effects on their secondary outcomes. So they looked at what's called executive function and processing speed, and they found that those were also different between the two groups, shown here. And there was no significant change on memory, which is the final graph right here, and you can see that those are very close together. They also looked at other factors, and they found a significant effect on BMI, on diet and physical exercise. They found good adherence at 2 years. And the real question about whether this is having any impact on Alzheimer's disease remains to be determined. But they are following people for 7 years, so they should be able to answer that question if they good compliance over that period of time. So the results, as I've shown you, are very small cognitive difference that we're seeing. But the important thing is that small differences like that can have huge public health implications, as I showed you with the YAFI data. That changing things just by 10% could actually have a huge impact on the number of cases. So even though this is small, in the public health context, it may actually be quite meaningful. Back to Cache County. So we've decided it's not enough for us just to sit by knowing that some of these things might actually be useful. It's time to move this into action. So we've begun a study with my colleague Maria Norton, this is her baby, developed a method in conjunction with engineers at the University of Ulster to begin to look at ways that we might be able to encourage healthy lifestyle in people in middle age before the disease begins to develop. We think that starting earlier and getting people on healthy life plans is probably the important key to a lot of these lifestyle interventions, which are also based on empirical data. So they're targeting in the initial pilot work, which was announced, or which was presented at the AAIC meeting in July, looking at healthy lifestyle intervention, again, for middle-aged adults, based on evidence using mobile technology supported with daily interventions. And it's allowing individuals to self-select the behavioral domains that they want to work on that can fit into their schedules. Again, we're trying to make sure we can get people to adhere to these interventions. So I'm going to show you a little bit of what this is all about. The objectives of the study, which we're now expanding into Durham, are to develop a healthy promotion intervention which is designed to encourage lifestyle changes targeted to improve vascular health. So we believe that that's the pathway that's mediating the effect that we're seeing in Alzheimer's disease with these risk conditions. And we educate on a wide range of behavioral domains, but we allow the participants to choose which intervention they would like to do. And then we determine whether our focus on brain health and Alzheimer's disease risk reduction in conjunction with this technology can lead to short-term changes and importantly can lead to long-term changes. So our primary outcomes are not looking at cognition or measuring anything in this pilot study. They're really to look at intrinsic motivation to change, looking at evidence that people are beginning to change, and looking at reduction in subjective complaints. And then there's some secondary outcome measures that are your more traditional measures. If we have a full funded trial, we would, of course, look at these secondary outcomes in a more deliberate manner. So the pilot results, which we've now just published, included 146 people in their midlife. 104 were on treatment, 42 were on controls. They went on this for 6 months. The people that were in the control arm, we said, just go on with your life as usual, pretend you're not in a study, but you too can be included in the trial at the end of 6 months if you so choose. So everybody knew that they could get in if they wanted to. And it uses a smartphone technology that you can see here. A lot of people are getting into this space, working with technology to help with cognition. And of course, you know, I think there's good data now emerging that having wearable devices actually help people adhere to some of these lifestyle changes. So it's an app that provides daily suggestion pairs. It gives us a short snippet based on health literature, and it's behind it is actually the literature that supports the suggestion if they want to look at where that evidence is coming from. And then there's a daily tracker, and so they get cued to log in and tell the app what they've been doing that day on these 6 different performance domains. And then it provides feedback, so it gives a 5-star rating for each of the domains. So this is what it looks like. There are 164 different fact pairs. You can see the coach on the side. And the factoids are refreshed every 24 hours, and they'll say things like if somebody's working on the diet, it'll say consuming high amounts of processed food is related to cognitive decline, try eating a salad today, or something like that. And then they're asked these 12 questions, so their phone will ding and tell them it's time to log in, and each question relates to the domains that they're working on. It's on a nominal scale, and the answer value is based on what the recommendations are from the WHO and the CDC. And these are updated daily. So this is not going to sound that unusual to those of you that are wearing a Fitbit. You can get this kind of information with Fitbit. But what's nice is it's now linking also with the wearable devices. And they use a self-slider to log in what they're doing. And then at the end, they're given a 5-star rating in each of the domains to encourage or reinforce the behavior. So to date, they've had over 122,000 responses that were logged, and they were able to look at some of their initial outcomes. So from the pilot study that was just reported, they looked at the difference between the treatment and control group, and they found that motivation was to improve was increased, so that was good. There were decreased cognitive concerns over the 6-month interval, increased social engagement, and improvements in cholesterol. They also looked at some of the biomarker data. They had to look at the people that were not physically active when they got into the study to really be able to see if they were seeing any movement in their biomarkers. So when they looked at that subset, they did see some improvements in terms of cholesterol, glucose, and reported levels of depression. And then they assessed at the end of the trial whether or not people were intending. Of course, intention and actually doing are 2 different things, but the vast majority of people indicated that they were intending to continue, definitely would continue, and a smaller percentage, perhaps as much as 20 to 30%, were more in the equivocal area. So, this is not necessarily something that I would say is the do-all and end-all, but again, I think it's beginning to introduce the idea of taking advantage of technology to help people affect lifestyle changes and trying to improve upon it. We're now expanding this out into a much more diverse population in Durham and trying to improve upon the software. But we're finding that people are engaged with it, and I think there are a lot of other technologies like this that are coming out that are really helping people to monitor their lifestyle decisions and hopefully try and improve upon some of those bad habits. So lifestyle changes may have an impact on future risk. It remains to be determined. But what about those who are in the preclinical stage right now? Do we really believe that implementing these different approaches is going to have a meaningful impact on the progression of their disease? What do we do for those people that are at imminent risk of showing cognitive decline or who already have cognitive decline? We're going to require much more aggressive interventions at the point where people are beginning to show problems. And that's not to say that these lifestyle changes shouldn't also be done, but it's also going to require probably a more aggressive approach if we're going to try and stave off more decline. And it's going to be aimed at basically modifying the underlying pathology that's already in motion. So if you go to clinicaltrials.gov, you can get a good idea, a snapshot of the number of trials that are currently underway. This is a somewhat old slide, came from Jeff Cummings in 2014, that indicated that there were 413 clinical trials underway at that point in time. And you can see how they break out in terms of phase 1, phase 2, and phase 3. In a recent look that we did just a couple weeks ago in preparation for another meeting, the numbers are quite similar, actually, although the actual studies that are included in this denominator are not the same as what you see in this slide. And some of those are new compounds, immunotherapy. Some are for symptomatic, a lot like the drugs that we currently have available for Alzheimer's disease that treat just the symptoms. And then some were directed at multiple mechanisms. It's important to note that as many drug trials have entered the market, the success rate has been exceptionally low in Alzheimer's disease, so less than 1%. And that's despite really promising compounds. So I think we have a lot of work that's still ahead of us, but we continue to look. And part of the problem, we think, in finding treatments has been that we may have been starting the treatments too late. And I'm going to just talk a little bit about the current direction that we're going in terms of prevention research, which is not to wait until people actually have full-blown disease, but to back up and try to implement our therapies when people are just beginning to show memory changes. So this curve you see here are representing the continuum of Alzheimer's disease in the brain, people here that are in the silent stage, some that are showing the beginning symptoms, and those that are fully symptomatic. This is typically where the treatments have been started, or right in this window. And we're trying to bump them up right here. This is what I call the sweet spot. We want to get people when they're just beginning to develop clinical symptoms in our trials so that we have a chance to see whether or not the therapies are working. If we go way up here, which is obviously the ideal to start before they even begin to show a hint, we might be doing a trial for a very, very, very long period of time to see if it's effective. So this is really for clinical trials. This is the sweet spot that we want to get at right before people begin to show symptoms, because we may be just following them for a couple of years. Once we have a therapy, then we would like to start it here. But for trials, we do them here. And so there have been a number of trials that are now underway in this country that are aimed at exactly that sweet point in the curve. The studies are called prevention studies, but I caution these are not really prevention studies, these are really delay of onset studies. So to do a prevention study, you would need to follow people to make sure you truly prevented the illness, which means decades. So they're really to look at delay of onset. There's 2 studies that are putting people in because they have a genetic form of the disease, so that's the DIAN and the API study. There's another study called the A4 study, and that includes people that have high brain amyloid in the study, so they're already beginning to show the pathology of Alzheimer's in their brain, and it's testing agents that will lower amyloid in the brain with the hope that preventing the disease onset. And then there's our own Tomorrow study, and the Tomorrow study, you'll notice, looks like it's misspelled, but it's not. That's a study that's examining individuals who are at high risk of the disease because they have a bad form of the ApoE gene along with a bad form of the TOM40 gene, and hence the name Tomorrow. And in combination with age gives us some indication of what their risk might be in the next 3 years. The Tomorrow study started in June of 2013, and it involves 56 countries in the US, UK, Australia, Germany, and Switzerland. It currently has stopped its enrollment at 3,500. We have 3,494 that are continuing on in the study. We had some dropouts. They're all cognitively healthy adults over the age of 65. Some are at high risk, and there's a small portion that are at low risk for developing the illness based on that gene type that I was telling you about. And the study is testing a unique compound and a mechanism. We're using low-dose pioglitazone. It's a compound that has commonly been used to treat diabetes, but it's being used at a very, very low dose in this study. And it's been shown to have effects on mitochondria and cell energy metabolism at this low dose. And it also engages a whole broad range of targets that are affected in Alzheimer's disease, so we found that very appealing as well. But the main reason we're doing it is because of its effect on cellular energy. There are a variety of other studies that are now underway looking at a lot of different therapeutic agents. And although this is an old slide, over 5 years old, I just wanted to be able to illustrate that basically there are many different drugs in clinical trial development from the preclinical stage in animal models all the way through to drugs that are available. Excuse me. Okay. Importantly, these drugs are targeting different mechanisms that are believed to be affected in Alzheimer's disease. So some of the things that you see here in pink and red, excuse me, are targeting that, sorry. I think that's better, okay. Are targeting amyloid, so that main protein that's affected in Alzheimer's disease are the ones that are in pink. So some of these are working on aggregation, others are in different stages of amyloid processing. And then over here in blue, you have agents that are targeting the other abnormal protein tau, and then you have some that are in green that are targeting other mechanisms entirely. To treat Alzheimer's disease, which is a very complex illness, is likely going to take more than one compound. It's likely going to take a combination therapy. And I like to say that just like with cancer, we're not talking about Alzheimer's disease, we're talking about Alzheimer's diseases. And so it's going to require multiple therapies and probably a combination of therapy as well as with lifestyle changes to be able to have a measurable impact. And that's the direction that the field is beginning to move in, is to look at these combination therapies. So I hope that from the comments that I've shared with you today on population-based studies, that I've shown you some information that will provide you insights into how looking at large populations can not only tell us about trends that are occurring, but they can also give us some clues about the influence of different factors on disease risk. They can drive inquiry into what's causing this disease, and they can suggest mechanisms for potential treatments, and also point to other developments that might help in terms of developing drug targets. Studies in very long-lived populations, such as the Cache County Memory Study, demonstrate that while genetics are important to risk, that there's a lot that's not accounted for by genetics at this point, and that perhaps 20 to 30% of our population can survive into late old age without significant cognitive disorder. Evidence that I've shown you from across the globe is consistently showing that there seems to be a modifiable component, and that it seems to be associated with vascular risk conditions as well as lifestyle factors. Prevention strategies are now aimed at controlling these metabolic and vascular risk factors, with the hope that if we can't cure the disease, that we might at least be able to modify it a bit. Because the evidence is now so strong that there is a modifiable component to Alzheimer's disease, the Institute of Medicine and the Alzheimer's Association are now recommending that there are healthy habits that are good for the heart, and they are also good for the head, or good for the brain. So the World Dementia Council is encouraging all nations not only to invest in future research, but to incorporate dementia risk reduction measures into public health policies and into non-communicable disease strategy action plans. The fields of gerontology and behavioral sciences are ideally positioned to help in understanding the importance of improving public health and how to go about doing it through the careful development of empirical strategies, well supported, and not just having these kind of rash recommendations that often appear in the media, but actually are supported by science. If we are successful in this, we show the potential of improving vascular health in the short term, cognitive health in the long term, and potentially even delaying the onset of these devastating disorders. Successfully accomplishing what we want to do, and doing that by the year 2025, will require creative thinking. And it's going to require collaboration amongst multiple disciplines. This is the time for team science. It's going to involve psychology, gerontology, engineering, and experts in human factors. It's not going to come from just one laboratory. And there are already ample examples of where working together and leveraging technology can help support older adults and their function into retirement. So we have things that are emerging like brain fitness games and whatnot that remain to be seen whether or not those things are actually effective. But we already know that there's technology that are allowing people to stay in their home. So smart homes, social robots, assistive technology, telemedicine, and phone monitoring. So we know that technology can be used to keep people in their home. Why can it not also be helped to support cognitive function? There are unprecedented funding opportunities that are opening up or are open that are designed to motivate innovation in team science. They include the BRAIN initiative that I mentioned earlier, the AMP, or the Accelerating Medicine Partnerships for Alzheimer's Disease, and there are emerging challenges that are being driven from the private industry, such as the Alzheimer's XPRISES, that bring substantial monetary purses to the development of novel approaches to this disease. Envisioning a world with treatments for Alzheimer's by the year 2025, I believe, is achievable. And I think affecting a global solution is going to be immensely challenging. And I think that's going to require very careful thought leadership, which considers solutions that can be readily implemented in low and middle income populations where dementia will have its greatest impact, and where the resources to help people with cognitive impairment are both precious and scarce. And that will be our challenge in the years ahead. It's not just for the people who can pay for it, but for the people who can't pay for it, that we must make sure that our therapies reach. So what about Jane? Is it Alzheimer's? Is there anything I can do about it? Well, we'd say there's lots you can do about it. First, we would always recommend treat what you can treat. So getting to a medical doctor and making sure that any type of medical condition that's undetected is treated. Get active, watch your weight and your diet. Keep mind active with new things, socially engage. Stress reduction, which means getting sleep, which often people will have reduced sleep when they're under stress. And then look to the future, help and research. So for anyone out there that's from the public and sitting in on the talk here today, you can help us be a part of the solution. Join and partner with the scientists here at the University of Texas in implementing the research that will help this generation and the next generation. I want to thank all of my investigators at Cache County that are contributing to this work. The ones in purple are the ones involved with the gray matter study that I showed you here today. My team at the Bryan Alzheimer's Disease Research Center, and the many investigators that are involved in the global trial tomorrow. And I'd also like to thank you as well.
Well, I would like to thank Kathleen for a very clear, well-organized, and informative presentation. So rather than having questions now, we do have a reception outside, so I invite you all to take some appetizers and wine and visit with Kathleen and ask her questions and visit among yourselves. So thank you all for coming.
UTMB Health, working together to work wonders.